are going to be learning how to solve a new type of equation, and they are called rational equations. Your heading for today is obviously solving rational equations, and the lesson number is 10.4. As always, I encourage you to write today's date so that your notes are organized, okay? Rational equations, or I probably should have put solving rational equations. Lesson 10.4, and be sure to include today's date. First, let me state that a rational equation is an equation that has at least one rational expression. Now, you'll see some examples of these later, okay? But it's really quite simple what a rational equation is. A rational equation is an equation that has at least one rational expression. Next, please understand that these problems are sometimes long in training, so be ready to work hard today. There really is not much of a need for an introduction to this lesson, okay? There's not any history behind these types of problems or anything you need to know. It's just write down the steps and then get started working these out, okay? So let's go ahead and write down the steps that you'll be needing and then apply these steps to some examples. Step number 1, factor any numerators or denominators that can be factored. Eliminate fractions by finding a common denominator and multiplying both sides of the equation by this common denominator. Solve the leftover equation, so after you've eliminated your fractions, you're left over with an equation. Solve that equation. By the way, that equation sometimes will be a second degree, third degree, it can be whatever, okay? And then lastly, check for extraneous solutions. Now I'm going to explain all of these steps to you later and show you what we're doing and why and all that kind of stuff, okay? But just copy these down for now. If you need to pause the video, feel free to. I'm going to move on, okay? Let's look at 4 examples. Okay, example number 1, please copy this down. Now step 1 says to factor your numerators and denominators if possible. Well, none of these can be factored, guys. Look, they're just all monomials. Okay, so step 1 is done. Step 2 says to find a common denominator. Okay, find a common denominator. Now let's stop and let's talk about that for a second, okay? Just if you would, please forget this equation for just a second, okay? And listen to me. Don't copy this down, just watch. If you have 1/2 x minus 3/4 equals 7/8, alright? I taught you way back at the start of the year, and you've probably forgotten, and that's fine, but I taught you way back at the start of the year how to eliminate fractions. I taught you to find a common denominator and then multiply the common denominator through. So I have denominators of 2, 4, and 8. A common denominator for 2, 4, and 8 is 8. So I'm going to multiply the entire equation by 8. 8 over 1 times 1 over 2 gives you 4x. 8 over 1 times negative 3/4 gives you a negative 6. Your 4 would cancel into your 8. Twice, and 2 times 3 is 6. 8 over 1 times 7 over 8, your 8 would cancel with your 8 once. And 1 times 7 is 7. So by finding a common denominator and doing what? Multiplying it through, look what you're left over with. An equation with no what? Fractions. Okay, so that's why we do step 2. Okay, that's why we eliminate fractions by finding a common denominator and multiplying it through the equation. Alright? Now, by the way, notice this is a rational expression. Excuse me, a rational equation, because I have at least one rational expression. Here's a rational expression. Here's one. So I have a rational equation. Now, something new you've never done, at least not in Algebra 2 this year, is find a common denominator with variables. So let's get started. First of all, you must always compare monomials with monomials, binomials with binomials, trinomials with trinomials, etc. Okay? So what you do is you write down each denominator off to the side. There's one denominator, there's the next denominator, and there's the next denominator. Okay? Now, first of all, when you're dealing with monomials, look at the coefficients first. I have a coefficient of 1, 4, and also a 2. So I apologize, I shouldn't have said coefficients. Look at your numbers first. I have a 1, a 2, and a 4. Got it? What is a common denominator for 1, 2, and 4? 4 is. Now look at your x's. How many x's do you have here? 1. How many x's do you have here? 1. How many do you have here? None. Which denominator has the most x's? Well, this one and this one, they both have 1. So I put 1x. Now if this would have been a 2, right here, if that would have been a 2, then I would say how many x's are here? 2. How many are here? None. How many are here? 1. Which denominator has the most x's? This one. How many does it have? 2. So you'd put a 2 over here. So you go with the group that has the most. If there's a tie, like they both have a 1, then you put 1x. So we have found our common denominator. Now it's going to get a lot more confusing than that later on. But we're going to have binomials mixed in. Everything gets really confusing. So hang in there and take good notes. So I found my common denominator. And if you'll look at step 2, it says to multiply it through. So here we go. I'm going to multiply this side by 4x over 1. And I'm going to multiply this side here by 4x over 1. Because that's my common denominator. Alright? So here we go. 4x times 4x over 1 times 4x. Your x would cancel with your x, leaving you with 4. And 4 times 4 is 16. So I'm just going to put 4 times 4 for now. So 4 times 4. Alright? Now, 4x over 1 times 5 over 2, your 2 would cancel with your 4 2 times. So I have 2x times a positive 5. 2x times a positive 5. So I'm going to put positive 5 times 2x. There's a reason I'm writing out the multiplication and not actually doing the multiplication. If you'll trust me, there's a reason, because later on we're going to have binomials and you're going to want to keep your parentheses. You're going to have negative signs. So it's always safe just to write out your multiplication. It really is. Now I have negative 11 over 4x times 4x over 1. Your 4x cancels with your 4x. So negative 11 times 1 is negative 11. So I did it. I did step 2. Now step 3 says to solve the leftover equation. So here we go. Let's solve the leftover equation. Let's simplify first. 4 times 4 is 16. Positive 5 times 2x is positive 10x. Now let's bring this 16 over and make it a negative 16. So I'm left with 10x equals a negative 27. Divide both sides by 10, and x, a negative divided by a positive, is negative. 27 divided by 10 is 2.7. So I have my answer. Maybe. Look at step 4. Check for extraneous solutions. Okay? Now what that means is check your answers. Sometimes they're not going to work. Okay? Now let me pause for a second. Can I show you guys why you check for solutions without losing you here? Let's just take a side note for a second, okay? Let's just push this over here for a second. Forget about this problem, alright? Just for a second, okay? Let's start off with an easy, you don't have to take notes on this, just watch, okay? If I had x plus 5 equals 10, obviously the answer to this equation is what? 5, because 5 plus 5 is 10, correct? So you know what the answer is now. Let's say I multiplied everything by x, okay? You can do that. You can multiply an equation by anything as long as you do it to everything. So I'm going to multiply this equation by x. X times x is x squared. X times 5 is 5x. And x times 10 is 10x. Now let's solve this equation. We have an x squared, right? So get one side equal to 0, so bring the 10x over, make it a negative 10x. So now I'm left with x squared negative 5x equals 0. Now you know what to do. Factor, pull out an x, and you're left with x negative 5. Now take each group and set each group equal to 0, okay? Take this group and set it equal to 0, you get 0. Take this group and set it equal to 0, and you get 5. Now, let's go back to our original equation, which was this. Before I multiplied it by x, I had this for my equation. Alright, now, remember the answer was 5. But when I multiplied everything by x and then solved it, I have another answer. Look, I have an extra answer. 0. Well, 0 doesn't work. Put a 0 right here. 0 plus 5 equals 10. No way. Now, yes, 0, 5 satisfies this equation. But that's not the original equation. Here's the original equation. Okay, Mr. Arrowfine, what are you trying to say? I'm trying to say this. Anytime you multiply multiply an equation by a variable, sometimes you gain extra answers. I took this equation here. I multiplied it by x. I solved it and I gained an answer. Well, look at what you did over here, guys. Did you not multiply this equation by x? Sure you did. You multiplied this equation by 4x. Anytime you multiply an equation by a variable, you get sometimes, not always, sometimes extraneous solutions. So you have to go very, very far back to the original equation and check it in the original equation. So here's the original problem, okay? I'm going to put negative 2.7 in for x. So 4 over negative 2.7, positive 5 over 2, negative 11 over 4 times negative 2.7. Now use your calculators, is what they're there for, okay? So first of all, I'm just going to type all of this into this should be equals, sorry, and then a negative sign right here. There's a negative sign right here. Now, I'm going to take 4 divided by 2.7, alright? 4 divided by 2.7, and something did not work there. Gives me a big decimal, then plus 5 divided by 2, and then hit math, enter, enter, and you get this. You get 215 over 54. Now listen, if you've not learned how to use your fraction button yet on your calculator, whether you have a graphing calculator or not, you need to learn how to use it. Let me go over this again. 4 divided by negative 2.7. Actually, I did make a mistake here, and I apologize. I forgot the negative sign here. So 4 divided by negative 2.7, enter, plus 5 divided by 2, enter, math, enter, enter. You get this. I apologize, sorry. Here I am telling you guys to know how to work your calculators, and I can't work mine. 55 over 54, alright? Now, so I typed in 4 divided by negative 2.7, enter, plus 5 over 2, enter, then math, enter, enter, and this came up. Now, I'm going to type into my calculator. Don't forget there's a negative sign here, so put a negative sign. 11 divided by, and then put parentheses, 4 times negative 2.7, enter, and then math, enter, enter. And I'm not sure why I'm not getting the exact same fraction. Let me look at this again, because, I typed in the wrong number. So 11 divided by parentheses 4 times negative 2.7, enter, then math, enter, enter, gives you negative 55 over 54, but there's already a negative sign right here. Negative, negative makes it positive. You must get the same thing on both sides. You must. Okay? You must check it. It does check, so this is our answer. We'll practice more of these, okay? Alright, let's move on and try some harder problems. These are tough, I'm telling you guys. Alright, next problem. Okay, here we go. Step 1, factor. There's nothing I can factor. You cannot factor these binomials. You cannot factor anything, okay? Step 2, find your common denominator and multiply it through, okay? I'm going to put 7 over 1, alright? Alright, my first denominator is x negative 2. My next denominator is a 1. I don't worry about 1, so not a problem. Next denominator, x minus x negative 2. Now, you listen to me, guys. You compare monomials with monomials, binomials with binomials, trinomials with trinomials, etc. So, in the last problem, we had x, what do we have? We had x for a denominator, 2 for a denominator, and 4x for a denominator right here. All of those were monomials, so it was pretty easy. Look at your numbers first, and then your variables. Now we've got some binomials, so you're looking at groups of binomials. Watch. How many groups of x minus 2 do I have? 1. How many groups do I have here? 1. Which one has the most? Well, they both have 1. So your common denominator is simply x negative 2. That's it, Mr. Hart. Well, yeah, there's no monomials to compare. There's no binomials except for these two to compare. Now pretend this had been x plus 2, okay? Alright, how many groups of x minus 2? 1. How many groups of x minus 2 down here? None. Which group has the most? This one does, so you put 1. Then look at your x plus 2. How many groups of x plus 2? 1. How many groups of x plus 2? None. Which group has the most x plus 2s? This one. How many does it have? 1. So you put this. That would be your common denominator. You've must look at every binomial. Okay? Now, but we did have minus, so we're good. Now, but what if I would have had a 2 here? Okay, no problem. How many groups of x minus 2 do I have here? 2. How many groups here? 1. Which group has the most? This one. How many does it have? 2. So how many do I put here? 2. Okay, guys? Alright. So my common denominator is x negative 2. We're going to do a lot of those in your homework for practice, okay? So I'm going to multiply both sides by x negative 2 over 1. Alright? X negative 2 over 1. And here we go. X negative 2 over 1 times this fraction here. Your x negative 2 cancels with your x negative 2, leaving you with simply 5x. Now, students, moving on, we're going to multiply this side times x minus 2 over 1. Now, 7 over 1 times x negative 2 over 1, nothing cancels, so I have 7 times x negative 2. Got it? Now, multiply this fraction times this fraction. X negative 2 cancels with x negative 2. Leave me with 10 times 1 over 1, or 10 is a positive 10 because of that positive sign there. There we go, guys. Let's simplify and solve. Okay, so linear equation, pretty simple. 7 times x is 7x. 7 times negative 2 is negative 14. Positive 10. Next I have 5x equals 7x negative 4. Bring your 7x over and make it a negative 7x. And I'm left with negative 2x equals negative 4. Divide both sides by a negative 2. A negative divided by a negative is positive. 4 divided by 2 is 2, so there's my answer. Possibly, okay? Let's go check it in the original equation. So I have to, look at that, I get a 0 right there, look. So 5 times, put a 2 right here, 5 times 2 is 10. 2 minus 2 is 0, it fails right there. You can never have 0 in the denominator, guys. Never, okay? So, 2, it only has to fail one time, and the entire answer fails. Now, pretend I had 2 answers for a second, okay? Like, let's say I had x equals 2 and negative 3. Well, if 2 fails, that does not mean that negative 3 fails. Now, it might fail, it might not. You've got to check each answer individually. So, 2 does not work. So that's the only answer I had. It doesn't work, so the answer is no solution. So, Mr. Error, you're saying there's no number ever in our entire number system that will satisfy this equation. That's correct. Will not work. No solution. Okay? Let's try 2 more of these. Here we go. Alright, now, step 1, factor. I cannot factor this, or this, or this, or this, but I can factor that. That's perfect square. Perfect square, first term is positive, second term is negative, so I'm going to go ahead and put this. And that's the square root of x squared is x. The square root of 1 is 1. Make 1 positive, make 1 negative. There we go. That is my factorization. Alright. Now I'm probably going to rewrite that so it doesn't look so sloppy. Alright, so step 1 is done. I have factored everything that can be factored. Step 2, find the common denominator. So here's my first denominator. Write it over here. Here's my next denominator. X positive 1, x negative 1. Now, I see no monomials to compare, but let's pretend we had a 6 here. And let's pretend we had a 3x here. Just pretend for a second. Just listen. First of all, compare your monomial with your monomial, okay? You have a 3 and a 6. What's the common denominator for 3 and 6? 6. Then you have an x here, 1x, and no x here. Which group has the most x's? This one. How many? 1. So you'd put an x. And then you would compare your binomial binomials and go on from there, okay? So understand that. Alright, so we have no monomials. We have binomials only. So it doesn't matter where you start. I'm just going to start up here. I have x plus 1 here, one group, and one group here. So which denominator has the most of these binomials? Well, they both have 1. So I need 1 x plus 1. Now, how many groups of x minus 1 do I have here? 1. How many here? None. Which group has the most? This one. So I put 1x minus 1. And there we have it, students. There's your common denominator that you're going to multiply through. Okay? So there it is. And let's go ahead and take it and multiply it by this side over here. And we're going to take this and multiply it by this side over here also. Alright, and here we go. First of all, I'm multiplying this fraction times this fraction. X plus 1 would cancel with x plus 1, leaving you with x minus 1 times 4x plus 1. So I'm going to put x negative 1 times 4x plus 1 equals. Now I'm going to multiply this fraction here times this fraction here. Alright? This will cancel with this, leaving you with 12. 12 times 1, which is 12. Okay? Now I'm going to multiply this fraction times this fraction. We'll put it over 1, 3 over 1. Alright? So here we go. Obviously nothing cancels, so I simply take my top times my top. So it's a positive 3 times x positive 1, x negative 1. So we got a lot of work to do, don't we, guys? I told you these problems get long and tedious. So here we go. I'm not going to do all this work for you guys. We have done millions of these this year. A binomial times a binomial. Take the x, multiply it through, take the negative 1, multiply it through, and you'll get this right here. You'll get a negative 4, a positive 1, negative 3x, and a negative 1. Over here we will get, if you multiply a binomial times a binomial here, you will get x squared, negative 1. So if you multiply this parentheses here times this parentheses here, you will get this right here. So then you have a positive 3 right here, and a 12. Alright? Now take your 3 and multiply it through. You'll get positive 3. I brought the 12 down. Brought the 12 down. 3 times x squared, 3x squared. 3 times negative 1, negative 3. Now, students, I've done all my simplifying, okay? Here we go. Now, I have to, well, I realize I've got a quadratic equation, so I want to get one side equal to 0. Maybe I can factor or use the quadratic formula. So I'm going to bring this 3x squared over and make it negative 3x squared. I'm trying to get one side equal to 0. Bring your 12 over, makes it a negative 12. And also bring your 3 over and make it a positive 3. So let's see what we're left over with, okay? 4 minus 3 is 1x squared. Bring down your negative 3x. And then I have negative 13, positive 3, negative 10. So there we go. All of this simplified down to this, okay? So I might need to come back to this later in case I made a mistake. I hope I didn't. But in case I did, we'll shrink it and we'll stick it up here for now, alright? Now, I've got to finish solving this equation. So, here we go. Is this factorable? I think it is. I've got a trinomial. Pull out what's common. There's nothing common. Moving on from there, we then, notice my power here is twice as big as my power here. I have a lead coefficient of 1. That's good. So what two numbers would multiply together give me a negative 10. When added, you'll give me a negative 3. Well, I think of these two numbers right here. If you multiply those, you get a negative 10. If you combine those, you get a negative 3. So the factorization is x negative 5, x positive 2. There we go. Take this group, set it equal to 0 and solve, and you'll get 5. Take this group, set it equal to 0 and solve, and you'll get negative 2. So there's your two answers right there. Now, maybe they both work. Maybe none of them work. Maybe one of them works. Let's find out, okay? So here we go. Let's start with the 5 first. We can do a lot of this in our head, okay? for x. 4 times 5 is 20 plus 1 is 21. 5 plus 1 is 6 equals 12 over 5 times 5 is 25 minus 1 is 24 plus 3. Now, with your calculator, I'm going to take, well, we know that 12 over 24 is 1 half. So I have 1 half plus 3. That's 3 and 1 half. If I reduce this by 3, I get 7 over 2, which is 3 and a half. So I get 3 and a half equals 3 and a half. So this checks. Now I've got to check the 2, the negative 2. Put a negative 2 here, that's negative 8 plus 1 is negative 7. Put a negative 2 here, that's a negative 1 equals. Put a negative 2 here, negative 2 times negative 2 is 4 minus 1 is 3 plus 3. Alright, negative over a negative is a positive. 7 over 1 is 7. 12 divided by 3 is 4. And 4 plus 3 is 7. Checks. So both answers work. You've got to check your answers, okay, guys? Alright, one more. And then we'll go from there, okay? Okay, step 1. We're going to factor as much as we possibly can. This is not factorable, this is not, and this is not, but this is factorable. We can pull out something common. So we're going to pull an x out. When we do, we're left with x negative 1. That's not too bad, okay? So there's my denominator. Now, I'm going to write one denominator here. And my other denominator here. So students, there's my two denominators. Now let's find our common denominator. First of all, monomial. I see one monomial here, none here. So how many x's do I have? 1. How many down here? None. Don't say 1. Don't count this x. This is a binomial. Okay? So how many monomial x's? 1. How many here? None. Which group has the most? This one has 1. Now x minus 1. How many groups of x minus 1? 1. How many groups of x minus 1? 1. Which group has the most? Well, they both have 1, so I need 1. And there is my common denominator. I looked at all of my pieces over here, and I have my common denominator. Alright? So, let's go ahead and erase this, and let's go ahead and multiply both sides of our equation by our common denominator, okay? Here we go. Put this over 1. Put this over 1. And let's get after it. Here we go. Multiply this fraction times this fraction. Everything cancels, leaving you with a 1 here and a 1 here. 1 times 2 is 2. So I'm going to bring down a 2. 2 equals, now we're going to multiply this fraction times this fraction. X negative 1 cancels with x negative 1. Leaves you with a 1 here. Up here you have a 1 and an x. 1 times x. So 1 times x is x. Look at that, nothing to do. X equals 2. We're finished. There's nothing to solve. However, we gotta check our answer, okay? So here we go. Let's put a 2 in for x. 2 times 2 is 4, minus 2 is 2. So I have 2 over 2. 1 over, put a 2 in here, 2 minus 1 is 1. 2 over 2 is 1. 1 over 1 is 1. Checks. That's your answer. Now students, understand something. As you go through your homework, the problems are going to be much, we're going to start off easy like these and get more difficult. Toward the end,